Come on. All right. Good morning, everyone. Welcome to week 5 of this module. First of all, I hope all of you are doing well. Just a reminder quickly, please. Couple of things before we get started for the module. Number one, I hope all of you have received my email for the data set. Okay. We will be talking about the coursework that's on the agenda today. That's what we are going to start with. So very, very important discussion. If you have any questions, it's a great opportunity to clarify that. Number two, from the way we are going, most likely we will have the main hackathon in week 8, first session. Okay. We will decide upon the date as it needs to be the common slot between both the batches. But we'll keep it for week 8, which is the last week of the module. We wanted it in week 7, but then I thought, this would give you slightly a bit more time to practice so that we could do the hackathon in week 8. So prepare yourself, make sure that you're not traveling anywhere because this has to be live hackathon. Preferably, most importantly, it has to be in class. Those who are doing online will have to keep their cameras switched on and the session will also be recorded just to make sure that the camera was switched on throughout the hackathon. Also, you will be given a different login ID and password, and we'll talk about that closer to the hackathon date. It will not be this account that you will be using. These links will be disabled, so you will not have a common access. You will have your own username and password in order to access the Data IT platform. Week 7, we will be having the mock hackathon, which will help you understand what the hackathon is all about. And then you have enough practice so that you can get into week 8. The deadline for the second coursework, which is the coursework that we are going to discuss today, is 30th of July, which means you almost are getting 1 month to work on the final project. And these are the two assessment components for your module. Are there any questions to begin with? I will be explaining formally the coursework now, the 60%, and then we'll get started with officially the first AI algorithm other than regression, which is logistic regression. We'll partially build a use case today. It will also help you understand how you can approach your coursework with the same sort of pattern. And we'll discuss logistic regression. We'll start implementing it today, and we'll continue logistic regression the next session. And this week we should finish logistic regression. Next week we should finish 2 other algorithms, which is decision tree as well as clustering, which is one of the unsupervised learning. So you will have 3 to 4 algorithms at your disposal to do the hackathon as well as the main coursework. Okay. Any questions anyone has to begin with? All good?
Sir, I have a
yes.
question.
Go ahead, please.
So we do have the Global Business Immersion trip, which I believe is July 25th to August 2nd.
Okay.
So would this be clashing with that by any chance?
No, so week 8 would be, so this is week 5 going on now, and then week 6, week 7, week 8. No, week 8 would be the week which is 20 to 24.
Okay, thank you so
Yeah.
much.
Yes. Okay. Are you sure about this? Yes. Yesterday, in the PVG or for that, okay. I can check.
So it would be, I don't think she had like the cookies and all.
Okay.
Once it would be for.
We can check. Yeah, once it is there, we can work around the thing. So that's not an issue. We'll figure it out. Okay, so first things first, let's talk about the main thing, which is the coursework. But before that, those who came late can quickly scan, and then I'll close the attendance. Done? Has everyone scanned? All right. Let's move on to the coursework. Come in. Okay, so to get started with the coursework, I want to start with a warning, first of all. Because there's a general tendency that the moment you get the coursework, you actually search online, is similar data available and, can I find some solution online and do something? Let me openly tell you, these are mostly available online, which means these are live competitions from Kaggle, from where the data has been shared with you. So don't jump off your seat saying that, oh, the data set I got telecom, the similar data set is available online. Definitely, it has been taken from a live competition. And why I'm telling you this is sometimes we do get this response. So, oh, this is available online and there is some Python notebook, something, and if you haven't attended any of the classes, you'll just take the code and submit. This is completely different for multiple reasons. Number one, the data, the values have been changed. Okay. Which means, there is a possibility that around 7, 8 of you would have received the same data type, which means the telecom data. But within the data set, the values might be different and it might be slightly different here and there. Maybe the IDs are different, maybe the revenue is different and so on. So first of all, the data values are different, number one. And number two, the idea of taking a live competition data is for you to work on something which is more realistic, right? And trust me, there is nothing online where you have a ready data IQ solution for your project. So it wouldn't say, this is what it is and just go and use it. So taking any solution from online is completely out of picture. But does that mean that you should not search what is online? Absolutely no. You should search online. You should read what people have commented. You should read what solutions they have taken. You should read, possibly what would be a good use case from that data. All that is completely allowed. Okay. But don't think that, oh, there is a ready-made solution available and, I can do it, because you cannot do it. The data is different. The ready-made solution is not for a particular use case. It could be for any use case which is not relevant to what you're doing. And there is no solution where, they could do something on data IP for you. You will have to build this from scratch. So it's not a 2 or 3 day activity where you did some GPT, you finish something and upload. There is a whole process involved in doing this, and hence this is 60% of your overall assessment. Now, the biggest challenge for your coursework, which you will face going ahead, are basically two challenges. Number one, to find a suitable use case. Now, nothing has been given, right? When I send the email to you, you have these general guidelines available, which tells you how to do the coursework, and you have the data set available, and you have the description of the data. But there is nothing that says you need to predict this, you need to do that, you need to do this. There are no objectives given for the coursework. And that's one difficult part of the journey. How do you set that objective for yourself? Okay. And I would say, ideally, to set the objectives, wait for this week also, because this week we'll be doing a categorical prediction. You'll be seeing how logistic regression works. You'll be seeing a standard example on how we go through. And then the way you look at your data might actually differ. So wait for this week's session also. In the meantime, what can you do this week is do research. What those columns are, understand the columns. Check if there is some additional data that you can source. Do some pivot tables, understand the relationship, do some BI. So set the background this week, and for the AI part, start thinking of it after this week on what the objective can be, what can you apply, and so on. Okay, so that's challenge number one. Challenge number two is the data has been designed in a quite tricky way. And let me explain what I mean by that. So the thing is, when you start applying models and when you start getting results, you actually might think that, oh, I'm getting amazing results. I'm getting 99% accuracy. This looks like a great model and so on. Even if I take two variables, it's giving me 99. And those are the things that we really want you to work on the project. It's not that, oh, you got 99, that means it's an amazing work that you have done. As an analyst, how do you critique that? How do you say, 99 sounds too realistic? Too optimistic. Is this something correct that I've done? Are some variables there which are highly correlating with the dependent variable? Hence, I'm getting that kind of accuracy. Even if I'm getting 99% accuracy, does it look really accurate? Those are the things that you would question, you would go back, build the model, experiment, and that is the reason why this is the whole research project. Compared to the hackathon, where this angle is not there. In the hackathon, objective is given, you need to do this, you need to do that, you need to run the model, you need to get the accuracy, you need to interpret. That's it. There's no going back and forth, there's no looking at additional data, there's no setting up of the objectives, and all that component comes in this coursework, and that's why it's a bit different. Okay? These are general guidelines to begin with. Now, let's have a look at the document itself, which is available on My Learning, which also I have attached in your email. Now, let's see what are the things that needs to be done. First of all, let's look at the important aspects. 60% you already know that we need to do. Let's talk about the deliverable. Okay, so all of you know what the end result of the project is. There are two things that you will submit. What are the two things? PPT and recorded presentation, right? And again, PPT is not something that you need to dump everything and write the reports kind of thing. It's more about your own structure and what structure do you follow for the presentation. You can just upload the PPT directly. Just make sure that PPT has some screenshots of data IQ and, as an independent submission, it looks perfect. Of course, you are doing the recording, you are explaining, that's going to be in the recorded video. So no Word document, no PDF, nothing. It's just one PowerPoint presentation. It could be any Prezi, Gamma, whatever you want to use, you can use. Presentation as a deliverable and recorded video as a deliverable. In the recorded video, it is very important for you to switch between what you're presenting versus what you're doing. For example, you would have done the things in data IQ. You would have made the model, you would have done the flow, you would have done prepare recipe, you would have transformed data, you would have run logistic regression, you would have run decision tree. So as and when you're explaining, keep switching tabs, right? So let's say you're on slide number 3, and now you say, okay, I will now show you what has been done in data transformation. You switch tab, come to data, you click on the prepare recipe, show the steps. This is step 1, step 2, step 3. This is the data type that you changed. These are the additional data points that you got. This is how you treated the missing value. Show them inside the platform. Once that is done, come back to the PowerPoint presentation. Now you say, now is the time I applied AI modeling, and I use 2 algorithms for my case study. I use logistic regression and I use decision tree. Then come back to data. Show how you implemented logistic regression, what were the results. Show how you did decision tree, what were the results, what did you change, and so on. So your recorded presentation, you should keep switching between PowerPoint and the actual project in data IQ, which you have done.
So the recorded presentation should be of how many?
So ideally we say 20 to 25 minutes, 30 minutes should be maximum, a good enough time for you to explain. But again, no hard and fast rule. So we don't say that, okay, if you exceed 5-10 minutes, there's a penalty or something. It's your space to explain, and if you need 5-10 minutes additional, ideally 20 to 25 minutes should be more than sufficient for the recorded presentation.
So first is like, you will use the same data IQ that you're currently using, you mentioned that it will.
Oh, that's a good question. The same one that we are currently using, that will continue only for the hackathon, because we don't want the sharing of the work. So let's say if you are doing the hackathon, someone can get into your folder and then see what you're doing. So we don't want that. For the research, does not matter. Anyway, the data is different, everything is different. So even if you're using this, you should be using the one that you're currently using.
And second is like we did the like similar video presentation in another module.
Okay,
But then the upload is limited to 100 MB itself. So-
500.
Okay, so for this it might be.
Yeah,
Then what if it was 100 and then we had 8-10 minutes for recording, it was very difficult.
Okay, so in this settings, I've kept 500 MB, but there are a lot of other options also. Let's say your recording exceeds the size. What you can do is upload a Word document with the URL. So you can either upload it on YouTube or on Drive or OneDrive and then give the link. But it's your responsibility then to make sure that the link is public. So it's not like, oh, when I'm evaluating, I cannot have access because by the time we are evaluating, all of you will be at different places. So then to chase you, or your URL is not reachable, then you will lose out. So if you are uploading the link, it's your responsibility that it has public access. So better, just even share it with me earlier that I'm going to use this link. But mostly with 500 MB, yeah, that should be good enough. Yeah. So yes, Tamil. Any other questions so far before I show you the structure of your postcode? All good? No questions? Okay, let's move on. Okay, now let's have a look at what are the various elements of your research project. Number one is domain knowledge and your research. Now, what do I mean by domain knowledge? Which you can start now. So basically, you have got the data set. Now you try and understand what these columns are, what do they mean, read some reports to understand what is happening in that industry. So some of you have got social media, some of you have got airlines, some of you have got telecom. There are various industries, right? So start reading a bit about what those columns actually mean. How significant are they in predicting anything in that industry? Is there some additional data that you can merge with the existing data? Start reading a bit about whatever you have got and increase your knowledge in that domain aspect. That's number one. Number two is identifying the objectives, which I said is the toughest part. What are you predicting at the end of the day? And this is going to be a prediction AI based, right? Now, how I would advise against any setting up of the objectives, and listen to this very carefully. So let's say you got flight accident data, okay? And one of the objectives that you are setting up for yourself is figuring out how many accidents took place in the last 5 years. Do you think it's a good objective or bad objective? What do you think? Not a good objective at all. Why I'm saying not a good objective? Anyone can just take average and done and dusted, right? That's not an objective for which you have to do a whole lot of research. Okay. So anything like that. So for example, what is the relationship between, let's say, some fuel and flight accidents? Again, it's a very small thing. You can do simple correlation to understand, the thing, or pivot table maybe, and then you can give the answer. So if your objective involves simple calculations, simple BI, simple pivot table, that's not a research objective. On the other hand, let's say you're saying, if you give me the parameters of an airplane, and if you give me the wind pressure, if you give me the humidity, if you give me the temperature, can I predict if something will go wrong? That's an interesting objective. That's where some research is required, right? There is an AI predictive element in that. So your objective should be futuristic, not past data. If it is past data, you're doing BI. You're doing pivot tables, summaries, and all that, which you should do, but only to enhance your knowledge, not to achieve a certain objective. So be very careful when you set an objective. It should be a research objective. It should have a prediction element involved. Is that clear with everyone? And once you have your, the whole objective, then of course the whole idea of storytelling, understanding the problem. Also, even if your objective is futuristic, is it relevant? I mean, will companies really benefit if they do this kind of a prediction? Okay. Will the industry benefit? Will customers benefit? Will someone benefit from your idea? All that is part of this domain knowledge and research. Now, most important thing, how many objectives should you have? Okay. Ideally only one that you should be targeting. Now, another question that I usually get, which you will get after you do some algorithms, is how many algorithms minimum should be implemented? Now, I would say we recommend a minimum of 2 algorithms. Okay, and listen to this very, very carefully. We recommend minimum of 2 algorithms. Now, you could do these 2 algorithms in 2 different ways. You could have 2 objectives and you could do one algorithm for objective 1 and another algorithm for objective 2. Something like supervised learning for objective 1, unsupervised learning for objective 2. That is one way of doing that. The other way is, no, I stick to one objective and I will try 2 algorithms of supervised learning and then compare which one is good, which one makes more sense, why you should pick one algorithm, why you should not pick one algorithm, and so on.
So how many objectives can we take and how many algorithms?
That's the great question. So let me put the names to the algorithm. We started with regression, which I would not recommend using for the project because they are mainly for numerical values. In this module and in this research project, you will mainly look at categorical algorithms, categorical prediction, which I'll come to. Today's session will start that. So I would say your algorithms are 4 in number. Logistic regression, decision tree, then you have k-means, which is unsupervised learning, and probably one more variation of unsupervised learning. So 2 supervised, 2 unsupervised. 4 algorithms is what you are playing with. And I would say either one objective with 2 algorithms or 2 objectives with 1 algorithm each. That's how you should play.
For example, sir, we take 3 objectives and then for one objective we can look at algorithms for decision tree and third the.
You can. So that's a good question. Does it stop you from choosing more than 2 objectives? No. What is expected from the coursework is 2 algorithms. Keep that in mind. Now these 2 algorithms could achieve 2 objectives or the 2 algorithms could achieve the same objective. So even if you do one objective, you still can score the best grades. Even if you choose 3 objectives, you might still not score the best grades, depending on what the objective is, how you have done it, how you have interpreted. So minimum 2 algorithms is what we are expecting. Yeah, everyone? Yeah? All right. Now, what are the other steps? Now, all this is initial work, research, domain knowledge, objectives, algorithms, and so on. Then you come to data preparation. There will be missing values, there will be outliers, there will be data type transformation, all what we are already doing in Data IQ, cleaning, importing, merging, etc., is another part of your research. Then comes model implementation, which is whatever algorithm you have chosen, you need to implement that model. You need to run that model in Data IQ. That's part number 3. And part 4 is visualization. Now, either you can do some graphs that can help you with the hypothesis. Maybe you can do some pivots that can help you with the hypothesis. Maybe there could be some charts that could come after the model implementation. So you can present those charts. Anything with a visual representation of data, either before the modeling or after the modeling, that can help you in your analysis. That's your part 4. And essentially, these are the 4 things that you are doing for your research project.
So did you upload this on MyLearning?
It's also there in the attachment. It's also there on MyLearn. I hope all of you got the email, right? So the PDF is there and the dataset is also there. Yes, PPT in a separate link, recorded video in a separate link. Correct. Okay, now the most important part. Everyone, please have a look. How would you structure your presentation? And this is the most important. What do you start with? Step 1, step 2, step 3, step 4. The first thing is in your presentation, you should start with introduction and domain knowledge. Okay. And don't go for the boring introduction that airline accidents are so many so far. Introduction means your research introduction. Okay. What did you do from a domain knowledge perspective? What are your objectives? How did you come up with that objective? Who will benefit from your idea? What is the kind of prediction that you're doing? All that is in step number 1, which is introduction plus domain knowledge. Step number 2, data preparation process. Tell us, how did you do your data preparation? First tell us, then go to data IQ, show us where did you do, and done and dusted. Part 3, visualizations. Did you do any pivot? Did you do any graphs to understand your data much better? Was there any visualization that helped you? The variable hypothesis, if you remember the trio, which variables you think are important? What is the hypothesis associated with that? Data availability, etc. All that comes in part 3, which is visualization. Part 4 is your AI model. Now, this is where you run the model, you show us the process, how many times you ran, what did you change, what results you got, were you happy with the results, did you run it again? Show us the entire process of model implementation. Last but not the least, now this is going to be interesting. You remember the Carrefour example that we discussed, delisting the product, right? And if you remember, we were actually doing the entire AI life cycle. And the last step of the life cycle was converting your idea into a product. Okay. Now don't get afraid. Don't get intimidated. You don't have to build the product here. Okay. But you can propose an idea. You can say, I did all this. I did the AI modeling. I did everything. If the company wants to use it, they can use it in this way. And you can tell how that product would look like. If you are enthusiastic a bit more, maybe you can prompt Claude or GPT to just give you a prototype and you can show some screenshots. So I'm not saying it should be a functional product, but just tell Claude or GPT that, I'm working on airline data. I want to develop a portal where people can enter the model number, can enter the temperature, can enter this. There should be a button called predict. It will show the probability. It will show this. Give all the inputs that you visualize the product should be, and AI will give you a nice prototype, and you can put the screenshots of the prototype in the final step, which is converting your idea into a product. And that completes the entire life cycle. You started with an idea, you did the data preparation, you looked at the research, you did visualizations, you did model implementation, you saw the results, and you converted your idea into a product. And that will finish the entire research project. So it's not something that can be done in 2 or 3 days. You need to play with it over a period of time, get friends with your own data and think of it as your work. And you should be proud at the end. If you can make a prototype and if you have done the modeling very nicely, you are able to build something very, very significant. Questions now? No questions? I thought everyone will be jumping around. Yeah, tell me.
So the processing should be live.
Not necessary. So that's a good question. Should it be live? I know you are quite enthusiastic in building with Claude and GPT. If you want, you can make it, but there are no sort of extra points on that. So don't stress around, I have to make a product, I have to make a product. It could be as simple as screens. You can have 3 or 4 screenshots and say, this is how your product should look like. The whole thing is, are you able to visualize what kind of product can be built, right? And can you show us that this is your vision? It could be with screenshots, it could be with a live product. If you want, you can build it. Why not with a link that say, you try and actually build this? So up to you. But no extra credits, it's just the way you want to express your final idea.
So we can add this in the resume.
100%, 100%. And this is what, when many people ask about job search and all that, I would say if you own your projects, you create visibility, you go to LinkedIn and say, I did this and, this was an innovative thing which I tried and so on. So this adds to your resume 100%. It's a full project that you are building end to end on a live industry data. Any other questions? No questions? Sorry?
Questions will come when we start.
Yeah, I 100% agree. And keep this in mind. So with every class that we meet, keep on asking questions so that others can also benefit with your questions. And then, of course, what I can also do is before you submit, I'll create a draft version also, not of the recorded presentation, but at least of the PPT so that I can see what flow structure you're using. And if you're going extremely in wrong direction, I can alert you. And I would say this is not of the quality that we expect. So we will have a draft link where you can have one feedback before you actually submit your paper. Okay. Last but not the least, the marking criteria is given, standard. It's basically if you have done everything. So your presentation overall is 40 marks, introduction, domain knowledge, data preparation, model, visualization, product. So standard marking, basically checking all the lists. So it's a collective project. So on paper, we do put some marking criteria, but overall, we see the whole cycle, the whole pipeline. Okay.
We will use screenshots.
Correct.
But with the prototype before one more thing I wanted to add, can we use the Power BI dashboard as screenshots in order to?
You can, but the thing is, you're anyway using data IQ, so and it provides the same charts functionality. But if you're more comfortable building a dashboard in Power BI, no harm. So we are not, sticking to one tool per se. Whatever suits you, but since everything is already happening in data IQ,
But sir, we can definitely an API for Power BI and integrate into the.
you can, why? So if it suits, if you're more comfortable, fine. Any other questions, guys? Anything on the course form? Shall we move on to logistic regression? Yeah? Okay. All right, so let's get started with the official first algorithm for the prediction world. Second algorithm, we have already seen regression as one of the foundational algorithms. And before we switch to logistic regression, you need to understand the differences. Why now one more algorithm? When you can already predict with regression, why do you need logistic regression as a separate algorithm? And are they substitutes of each other? Can regression and logistic regression achieve the same purpose, or are they actually meant to do different jobs? And how does it do differently is what we are going to see today. Let me do a quick recap. When we did regression, was that pure AI or machine learning? Machine learning, because historical data was there. When we did the final prediction challenge, was it supervised learning or unsupervised learning? Supervised learning, 100%. There was one variable that you were predicting. And what was that one variable in the final prediction challenge? What were we predicting? Sales, right? Sales of a company. That's the variable. And which variables were helping us predict sales? Week number, right? Nothing else. We just took one on one. Hence, we didn't have any other variables which were helping us predict the sales. Now, I will continue regression itself a bit before I move on to logistic regression. And please observe this carefully. I'm going to ask you a lot of questions. Now imagine, and this was, actually one of the case studies which we did with Majid Al Fateh. So, the idea was whenever a new tenant comes to the mall, we used to predict the revenue of a tenant for the next 2-3 years. You would ask, why do you want to predict the revenue of Starbucks coming to Mall of the Emirates? The reason is, all your mall, they share a percentage of revenue to us. I mean, the logic is you're in the mall and your footfall is your footfall, but you are getting additional footfall because of the mall, right? And if you're getting additional footfall because of our initiatives, we need some percentage in that. And that's a standard practice in all the malls. But the problem is, some tenants were not happy when they were not doing well. So they would say, look, I'm already doing bad. There are no customers and I'm paying you 20% of the revenue, which is not fair. On the other hand, on the other hand, some tenants might be doing extremely well. Okay, they are minting money because of the footfall, and they are paying only 5%. And we would say, what if it was 7%? What if it was 8%? It would have been great for bank. So what we did started doing for every tenant based on the location in the mall, we started predicting how much they will make in the next 2-3 years. And based on that, we used to charge a percentage of the revenue. Okay. Now, answer the following questions. Is this use case supervised learning or unsupervised learning? Think again. Why? Why supervised? Why unsupervised? Tell us why supervised? Only targeting revenue. That's it. That answers your question. You are predicting revenue. Everything else, the position in the mall, the brand equity, the existing number of competitors, category performance, economic indicators, they are all helping me predict that single variable, which is revenue. Again, one variable that we are targeting, perfect example of supervised learning. Everything else that is helping me predict that revenue is X1, X2, X3, X4, X5, X6, X7. And this is basically your case study, your research project. If you can figure out what you're predicting, which is the objective of the use case, half of your job is done. Then you figure out which variables can help you predict that variable, which is X1, X2, X3, X4. The other half is done. And that's where the toughest part of your project is, to find out what you're predicting, to find out which variables can help you predict that one variable. Okay. Now, imagine we did this. Okay. I ran regression. Regression is a suitable algorithm. I'm predicting revenue, which is Y. Have a look at the equation. Okay. I'm predicting revenue, which is Y. Let's assume I have taken 4 variables. X1, X2, X3, and X4. X1 is brand equity, which tells how strong the brand of the tenant is when they are coming to the mall. X2 is number of competitors. X3 is distance from the anchor stores. Basically, how far away are you from the hotspots of the mall? And the idea is, if you're very far away, you might get less footfall. If you're closer to the hotspots, you might get more footfall. And X4 is previous sales of the tenant. So if Starbucks has already been doing well, there's very high chance that they might do well when they come here. Ideally, we would follow the same process of hypothesis, which will affect how and so on, data availability and all that. Imagine we did everything and we ran the equation. We ran regression. We actually ran regression, by the way. And we got a result like this. Okay. Now, math is asking you, good job. You ran the regression. Let's assume, things are looking, R-square value is looking good. Let's say it is 0.85, which means you can trust the equation. That means you are ready to predict. You can say, okay, tell me the brand equity, tell me the existing number of competitors, tell me the distance from the store, tell me the previous sales of the tenant. I can predict the revenue of a new tenant. Very much possible. Put the value of X1, X2, X3, X4, get the value of Y. That's how you use it for prediction. Now, answer this question. Math is asking you, you took 4 variables, okay, for helping you predict the revenue. Which out of the 4 variables is the biggest impactor on revenue? How would you answer that question? Which variable out of the 4 is the biggest influencer in predicting the revenue of a tenant? Previous sales, he says. Hotspot, he says. Have a look. Which one is the biggest influencer in predicting the revenue? Brand equity? Others? In order to answer this question, you need to understand what those numbers mean. Okay. Let's see what this 2 means. What is -3? what is 4, what is 5.5. These are 4 numbers that you have to be careful about. Let's talk about X1, which is brand equity. Okay. Can anyone tell me how do I interpret that number 2? How do I explain it to math? What is 2x1? Sorry? What is 2x1? How do I explain that 2? You can see 2x1. X1 is brand equity. Y is revenue. Now, how do I tell to math? Revenue is always double of equity. Equity is the double of revenue. Okay. Anyone else? Keep guessing. This is how you maths become quite interesting. How do I explain it to math? 2x1.
The brand in 1 unit.
Okay.
The revenue increases by 2.
That's a better explanation. Now, everyone, please listen. What she said. When the brand equity increases by 1 unit, the impact on the revenue will be, it will become double. Which is right. So I don't know what the unit of brand equity is. Maybe it's a scale of 1 to 10. So if the score is 4 and I change it to 5, provided other variables remain constant, then the revenue is almost getting doubled up. That's what plus 2 means. If that is plus 2, can anyone give me an interpretation of number of competitors? Anyone else? More the number of competitors, lesser would be the revenue. And if they ask how many times less? 3 times. One increase in one competitor will result in reduction of revenue by 3 times. That's how I read -3. Similarly, +4, which is distance from the anchor store. As your distance from the anchor store increases, then the revenue increases 4 times. Now, this is where you would think, is that logical? Is that not? And that's why hypothesis is important. In your hypothesis, you said the more away they are from the anchor stores, lesser should be the revenue. But now you got something opposite. Is it truly opposite or you made some mistake? That's how you go back and check. Similarly, 5.5. As the previous sales increases by 1 unit, the impact on the revenue is 5.5 times higher. Independently, if we compare X1, X2, X3, X4, which one do you think has the highest impact on revenue? Positive or negative combined? Previous sales, which is 5.59. So it's one of the biggest influencer in predicting your revenue. Of course, you need to look at another mathematical parameter in regression called p-values, which tells you whether they are significant or not. But otherwise, these coefficients tell you the importance of the variables. Good news in data IQ, you don't care. I mean, the tool is quite amazing. So what it does, it looks at the coefficient, it looks at the p-values, it looks at everything for you, and it gives you a nice visual. And it will say, of all the 10 variables that you consider, these are the top 4 that are predicting your whatever you want to predict, right? And it will also order them. Which one is most important, which one is less important, and so on. It will give you a perfect visual summary and everything, which is the greatness of the platform. In a coding world, you would have scratched your head on, okay, where are the coefficients, where are the p-values, and you run another code to, order them in a sequence, no visuals, no graphs. But in data IQ, when you run the model, it will tell you. It will tell you A to Z of which variables were important, which variables were not, which is most impactful, which is less impactful, so that you can make your model much, much better. This is so far a regression. Now, same thing applies in logistic regression also. Please listen very, very carefully because this would help you understand why do we need logistic regression. Exactly the same thing applies in logistic regression, which means you're predicting something that becomes your Y. There are lists of independent variables, which is X1, X2, X3, X4. Exactly the same thing. There is only one difference on why we choose logistic regression instead of regression. And in order to answer that question, I will ask you another question. In regression, what do you think are the allowed data types for x1, x2, x3, x4? And let me give you some options. Can I have any one of the x1, x2, x3, x4, x5 as a text variable? 100% not, out of question. So for example, if name is one of the variables, you can't put name in x1, x2, 100% string text is out. Can x1, x2, x3, x4 be a categorical variable? Can any one of the x1, let me give you an example. Let's say instead of taking previous sales, can I take a variable which says good sales or bad sales? You can? Absolutely yes. Any one of your x1, x2, x3, x4 can be a categorical variable. It can be a binomial variable like good or bad. It can also be which group the tenants belong to. Is it group 1, category 2 or category 3? 100% allowed. No problem in regression. Which means your x1, x2, x3, x4 can take categorical variables, can take numerical variables. 100% numerical also allowed. What it cannot take is a string. Now let's come to y, the dependent variable. Now, can that be a string? Can you predict the text? What do you think? So for example, there is a column called name. Can you run a model that can predict name for you? 100% no. That's weird kind of a modeling. Can that y be numerical? An actual number? What do you think? Yes or no? Can the y be numerical, an actual number? Yes, 100%. That's what we are doing. Revenue of a tenant is an actual prediction. Sales, which we did last time, is an actual number, right? All what we have seen so far, there is a numerical prediction. And now the most important part. Can that y be categorical variable? Let's say you want to predict whether a country will win a match or not. Unfortunately, not. And that's where regression says, thank you, our relationship was only till here. Now you want to do a categorical prediction? Goodbye. I cannot do categorical prediction for you. Regression cannot tell you whether some country will win a match or not. Regression cannot tell you whether it will rain or not. Regression cannot predict whether you will pass or fail in an examination or not. The moment categorical predictions comes in, regression says, done and dusted, my job is done. I give this job to logistic regression, which is where there is a set of algorithms that can do categorical prediction for you. Now, this becomes very, very important. Whatever you are predicting, if it is numerical in nature, regression can do the job. Okay. However, if you are doing a categorical prediction, which is where most of the AI world today is doing, the prediction of good or bad, the prediction of sales, good or bad, whether it will rain tomorrow or not, whether a customer would default a loan or not, whether an employee will leave the organization or not. Majority of these categorical predictions are not done cannot be done. Not that regression should not do, cannot be done by regression. And there is a reason why regression cannot do. I'll show you the reason. Let's have a look. So we did all this. 1 minute. Okay, everyone, have a look here. Why regression fails? Have a look at this graph and let's circle back to our last class. In the last class, we did regression, right? What were the two variables over there? What were we predicting? Sales. And what was the other variable? Day number or week number, right? What we did, we said first plot the X and Y, okay? Find the best fit, which is the trend line, which can connect all the dots together, get the equation of that line, and then and dust it, right? Let's apply the same logic here. What difference do you see between this X and Y? So by the way, income is on the X axis and whether a person will vote is on the Y axis. Okay. On the X axis, it is income. And on the Y axis is whether someone will vote or not. And that's what you're predicting. Whether someone will vote in an election or not based on the income. Now, what do you think is different of this graph compared to what we did earlier? Why?
What's that in computing regression?
Exactly. Now have a look here. So some of the dots are here and the other dots are here. Now what line are you talking about? What trend are you talking about? What exponential, what polynomial, what linear? There is nothing in the world that can in any way connect, all the dots even close by together. That's why regression says, sorry, the line of best fit does not exist when the data becomes categorical. When it is not categorical, it is numeric, I can fit a line for you, I can fit a trend for you. But when it is two opposite poles, I'm sorry, I cannot fit anything here. You need a separate maths altogether. And hence the maths of, odds ratio comes in and logit and log of odds ratio and all those drama came in order to give birth to another algorithm, which is called logistic regression. However, you need to be a bit careful when you do logistic regression. So let me come to this and don't get intimidated. I'll just tell you one thing. You saw the equation for regression, y equal to something x plus something x plus something x3 plus something x4. That's how regression, linear equation looks like. A logistic regression equation looks something like this. Log of odds ratio. Okay, so odds ratio is the odds of winning the game or odds of getting a bad mark, odds of losing a game, odds of raining tomorrow, categorical prediction. Log of that whole bracket is odds ratio equal to something x1, something x2, something x3. Question to you. Which side of the equation resembles regression? The right side is exactly the same. Something x1 plus something x2, which means everything is the same. You identify x1, x2, x3, it will give you a relationship. However, there is one major difference. In regression, when you put the value of x, you get the value of y. In the previous example, you put the value of x1, x2, x3, x4, you get the value of y. That's what you were predicting, right? You're predicting sales, you got sales. Here, when you put the value of x1, x2, x3, x4, you don't get y directly. You get the log of odds ratio of y, from which you can calculate probability of y, and from that probability, you can decide whether you consider this as win or lose, whether you consider this as rain or not rain, whether you consider this as default or not default. Algorithm does not directly predict that. It gives you a probability. Now you put a benchmark to the probability and you say anything above 0.5 is I consider yes, anything below 0.5 I consider no. So remember, logistic regression never predicts directly. It only gives you a probability, which is great in a way, because imagine you're a bank manager. A customer is coming to you applying for loan. At one end, you're saying, oh, I am seeing only two results, whether this customer will default the loan or not. At the other end, you're getting a probability. You're saying the probability that this customer will not pay back the loan is 0.9. It's a very high probability. Versus another customer coming and saying the probability is 0.55. There is a difference of this customer versus that customer. So as a manager, you take better decisions. Maybe 0.55, I would say, maybe I'll approve the loan. But 0.95, I would say there's a very high chance that the customer will not pay back the loan. So I can take a decision of not approving. The summary of all this is two things. Whenever you're doing a categorical prediction, go for logistic regression. Whenever you're doing a numerical prediction, go for regression. Everything else remains the same. Major difference number two. In regression, when you put the value of x or x1, x2, x3, you get what you're predicting. In logistic regression, when you put the value of x1, x2, x3, you don't get directly whether someone would pass or fail the exam. You get the probability of passing the exam, from which you can decide, do you consider this as pass or fail? Again, the good news. Data IQ takes everything off from you. Just don't worry about log of odds ratio and probability. It says if you want, I can give you. If you want to see the probability for every customer, I'll show you the probability of loan default. But what I will do is I'll assume 0.5. Anything above 0.5 is yes. Anything below 0.5 is no. I can give you direct predictions. But that does not mean that the algorithm is giving you direct predictions. It's giving you the probability. That's what the algorithm is designed to do, to give you a probability, and then based on that, you decide where it can go, here or there. Also, one important piece of information, logistic regression not only predicts two categories, it could be multiple categories, right? For example, there is a customer loyalty program of gold, silver, and bronze. A new customer is coming in, and you want to predict eventually which category this new customer will belong to in future. It could be gold, it could be bronze, it could be silver. There could be three categories, two categories, does not matter. If it is categorical prediction that you're doing, then you are going for logistic regression. Don't get disheartened by the maths of it. As I said, the tool is phenomenal. It takes away everything. You don't literally put the value of x1, x2, x3 and calculate the equation and all that. Everything is done by the tool. It just says, do you know what algorithm you are applying? That's it. I will help you with everything else. It will also tell you which one of the x1, x2, x3, x4 are the most important variables in predicting what you are predicting, which one is positively affecting what you are predicting, which one is negatively affecting what you are predicting. Everything the tool will visually compute for you, but essentially it's all coming from this equation.
Does the whole logistic regression process?
Very good question. So for both of them, essentially the same. So the constant is the constant value in regression. Constant is also the same in logistic regression. It essentially gives you a starting point, which means if all the independent variables are zero, what does the predictor look like? So it's the slope that it gives, and it's the same interpretation. Oh, good question. Any other questions? If not, I'll ask you a couple of questions before we take a break and get started implementing logistics trader. No questions? Okay. What I want you to do is give me some realistic use cases of logistic regression other than the ones that I have mentioned. So I have mentioned loan default, yes or no. I have mentioned you pass or fail in an examination. I have mentioned whether it will rain tomorrow or not. It's a categorical prediction. Other than that, can you give me some realistic categorical prediction?
Piece of petrol.
Very good. Classic case, you have all the historical data that you need. Would next month lead to an increase or decrease? That's what you're predicting. Fantastic use case. What are the variables that can help you predict? Historical data, of course, historical prices. It could be, let's say, the current economic conditions. It could be buying behavior, the existing population or the number of people who have traveled versus not. All these are X1, X2, X3, X4. Why is whether it will increase or decrease. I love that use case. Anything else? Elections, whether someone would win an election or not.
Pricing of goes due to war.
Fantastic. Now you are trying to see the impact of regional situation on increase or decrease in prices. So two categories, will it go up? Will it go down? Stock market is a classic example. Every up and down is logistic regression, decision tree. These are all the algorithms which are working at the back end to predict whether stock prices would go up or down. Anything else?
Gold price.
Gold price, 100%, will it go up or down? And again, you can have timed intervals. Are you taking day level data? Are you taking hourly data? Are you taking this? And accordingly, you can predict whether it will go up or down. So anything categorical in nature is something that you can use logistic regression. And why this is an important piece of information is now you can go back and look at the data that was assigned to you. Look at all the columns. And you can say, oh, is there anything categorical in this? Can I have some categorical predictions? Don't have a look at it now. I'm just telling you can have a look. One final question. Let's say the data set that I give you has no column which is categorical in nature. Everything is numerical, let's say. Can you still apply logistic regression? How?
If there is a futuristic value you want to predict,
Hmm.
like there's no column that says, it's categorical. But then if you want to predict something that you think is a yes or no, or it is
Correct. That's a good point. But the problem with that approach is anything that you want to predict, there has to be a historical data for that. So if you want to predict yes or no, there has to be some yes or no from the existing data that it can learn from. And this is exactly my question. You don't have any categorical values. Can you still predict something categorical? What do you think?
So is it necessary for the historical data to be there?
It has to be. That's just machine learning. That is machine learning. Think about this. No? Take a guess. Yes or no? Can we predict categorical if there is no categorical in the data? Okay, let me. How many of you got airline accident data? If you have checked your data already. One. Okay. Now let me give you an example. Let's say, and please listen very carefully because this is applicable in all your things. Or even better example is carbon emissions. There is one sustainability data as well. So imagine there is one column which is actually the actual carbon emissions. Okay. And now I'm looking at that column and I'm saying this is a numerical data. I cannot do categorical prediction. However, I can look at that column and I can say, okay, the average carbon emissions are 20,000 in that entire column. What I can do is I can convert that column into categorical. And I can say, if the carbon emissions are greater than 20,000, then it is bad, else it is good. Which means I did not have it, but I made it. And now I'm predicting that a future company which has this, whether they will have good carbon emissions or whether they will have bad carbon emissions. Absolutely doable. Same case with sales data. You have the actual numbers and you can create three categories of sales. Anything above this is excellent. Anything between this and this is medium. Anything between this and this is poor. Now we have three categories. Excellent sales, medium or poor. And now we are saying, I will do a prediction for the company that next year, will it be average, will it be excellent, or will it be poor? Fantastic example of logistic regression. So even if you don't have a numerical data, does not mean, and in fact, many companies prefer categorical prediction because numerical prediction is to get it right is very, very tough, right? To get the exact sales for next year, very hard to have a very close number. So they would say, let's create categories of sales instead of exact sales number, whether we'll be grade 1, grade 2, grade 3, or grade 4, first convert it and then predict it, which could be very well done in your use case as well. Okay? Any final questions? After we come back, all data I give. I'll give you a superb data set on Titanic's survivors when the disaster actually happened. And we are about to build a model on whether a passenger could have survived that disaster or not. So something which is considered the Bible of AI predictive modeling. Okay. Any other questions? All right. So the time is 10:40. Let's come back at 10:55. 5 minutes to 11. Okay. Thank you.
Hello, sir.
Sorry. Yes. Go ahead, please.
My apologies. I just had one question.
Yeah.
See, we have like around, I think, 13 students who are
Mhm.
attending online today.
Okay.
How many of the students in the class are attending physically?
So around 30.
30.
Yeah.
So
So there are
that means
45.
45. Okay.
Yeah.
All right. All right. Thank you so much.
Okay.